Okay, hello and welcome to my channel. Today we're gonna talk some about momentum space and the Dirac delta function. So let's start with momentum space. Now, what do I mean by momentum space? Well, as you know, when you have a wave function, a psi of x and t, you can do the Fourier transform to put it in the k space to localize it. Yeah, to localize it. For example, your wave in x is all over the place, and when you transform it to the k space, it would just be around a point x naught. But for example, what if you want to put it in momentum space? Well, as we know, momentum and the p and the k has a very close relationship with each other. So we'll see right now how we gonna do that. So let's start by just writing the normal Fourier transform. We're gonna see Fourier transform a bunch of time now. And pi, put down this kx and your phi k 2 pi delta x e minus kx. So that's for p. And when you have these two, you already know that this guy here, your phi of k is kind of like the thing that measures the contribution of it. Well, you could one way to put it is that like it's like the weight of the plane waves in the superposition. Well, kind of hard to understand, but you just have to know that this guy kind of govern over like how much contribution it's gonna make. So we can put this back to that and get something like psi of x here would be a dx prime. So a different x because we do this and we put it back here, psi of x prime, and another dk of your function. Now k is gone. You put the phi k back here. So now this part would be only e I got a different k. We got a different x and a different we only got a different x this time. Would be x minus x prime times okay, I forgot that part. Would be, let's just put it here, over 2 pi. And for this to look a little bit more correctly, nothing wrong with this, but for it to look a little bit more right, would take somehow we would want to invert this part and make this x prime minus x. So one way to do this is that you take k to be to you would move k to minus k instead. So you would do something like k goes to minus k. Now your psi of x would be equal to prime x prime k e I k x minus x 1/2 pi. And get that, and this part right here is what we call a Dirac delta function, and people write it like this right here, 1/2 k x prime minus x would equal to delta x prime minus x. And this guy is the Dirac delta function. It has some properties. It is symmetrical, and when you time it with a power, so symmetrical, and you got a power for it, kind of like in delta function, when you got a power, it would equal to 1 over the absolute value of alpha times itself in x only. And what this does is that it is essentially a kind of like a sifter, so it gonna look for like specific points, kind of like a sifting tool, and it will locate specific points on your function. And yeah, that's it for today. Bye.